Across official documentation and open source contributors, countless templates exist to create Marlowe code. As discussed in the DeFi primitives section, this by itself may not solve your problem, but it can become part of your solution. JSON files with examples are available on our project GitHub. These cover airdrop, swap, pawn, shared ownership, collateralization of tokens, auctions, oracles, and royalties. Combined with the basic building blocks from Playground and slight modification using the convenience of Blockly and powerful smart contracts emerge. Then, simply put them through simulation, deploy to testnet using Runner, and reuse the JSON inside your Web 2 app for the Web 3 on-chain modules. Decentralization and transparency of the Cardano blockchain will become easily available for your users. This airdrop example demonstrates distributing native tokens to multiple recipients using Marlowe. It highlights an important technical constraint. Plutus execution costs limit how many payments can occur in a single transaction. The process involves 9 separate transactions. First, Christopher Marlowe creates the contract on the blockchain. He then deposits 500 Bear Garden tokens into this contract, which will be distributed to 5 different recipients. After a 10-minute waiting period, Christopher initiates the distribution. Due to execution cost limitations, he must split the distribution into 2 separate notification transactions. The first notification triggers payments to some recipients, while the second completes the remaining payments. Following the distribution, each recipient individually withdraws their 100 Bear Garden tokens from the Marlowe payout address. Francis, Elizabeth, Mary, Jane, and John each perform their own withdrawal transaction. This example illustrates both the capability of Marlowe to handle token distributions and the practical limitations imposed by the underlying Plutus execution model. The requirement to split payments across multiple transactions is an important consideration when designing token distribution mechanisms on Cardano. This example is stretching the limits of what we should package into a single Marlowe script. When combined with smart off-chain mechanics of your app, loops and off-chain whitelists could perform a lot of the heavy lifting. And then you assign roles instead of individual recipients of the airdrop or other cash flow. Combining the speed and low cost of your JavaScript app with TypeScript SDK access to the blockchain, where you need verification and immutable record keeping, can often provide the best of both worlds. On the other extreme end of the complexity spectrum is this simple token sale of the same native token. It is arguably less complexity than Playground templates, but provides useful information about assigning roles instead of using the blockchain address, hard-coding the asset identifier for any native token. Consider these approaches to reduce complexity. Move data preparation off-chain when possible. Complex calculations, data aggregation, and validation checks can often be handled by the dApp before submitting transactions, keeping the on-chain contract focused on essential logic. Use modular contract design by breaking down complex financial instruments into smaller, composable contracts that interact. This improves readability and makes testing more manageable, making use parameterization to create reusable contract templates rather than hard-coding values. For multi-step processes, consider whether state machines with clear transition rules might be more appropriate than deeply nested conditional structures. Finally, use the Marlowe Playground's simulation capabilities extensively to identify optimization opportunities before deployment. The visual nature of the simulation helps recognize patterns that could be simplified.